Okay, the next step of our quiz was based on this graph of f that I drew based on the asymptotes and the limits. Sketch the derivative. So the derivative is tracks the slope of this function. So I like looking for the slope that I often look for is about 1. 45-degree angles basically is what I look for. So here, this function has a slope of about 1. So at this value of x, right, the value of the derivative function will be 1. And then I look for extremes. So it's also here the case. So this is about a 45-degree angle, say. And here, the derivative function, this is the slope is 1 here, positive 1. So right here, at this x value, my derivative function is going to be 1 as well. And then I look at, for flat sections, this area out here is almost 0, but it's just still slightly positive, but almost 0. So at in this range, my derivative function is almost 0 with just slightly positive values. This function here, the value rises. The slope is a very steep positive value. So close to the vertical asymptote, my derivative function measures a large positive slope. So this is going to have a large positive value. So I can get a sense that my derivative function fades towards 0 here, remaining with a slight positive value above the x-axis. It rises to about 1 here, and then it rises to a large value approaching this asymptote. Now this function, we already know the point on this, we already know one point here on the left side. And now I look and I notice that way out here, the slope is nearly 0, but slightly positive. So I know that in this range, my derivative function is nearly 0 and slightly more than 0, not slightly less than 0. And here the slope is very steep again, and as the slope of the function f is steep, so my value for the derivative function is also high as we approach this vertical asymptote. So this is f prime. That's a graph of the derivative of the function f, and the derivative function measures the slope of function f. Okay, that was a sketch of a function, and now we're going to use the definition of derivative to find f prime explicitly, but I'm going to do that in the next video.